Now clearly this is 1 to the power infinite form, and for 1 to the power infinite form we have this shortcut. So if we have any limit which is limit x tends to a fx to the power gx, and the form is 1 to the power infinite, we can write this as e to the power limit x tends to a gx into fx minus 1. Now let this limit be L. Now we can write this as L equals e to the power limit x tends to infinite. Now that's your gx, x plus 1 by 3 into fx minus 1. Now we subtract 1 from it, it will be minus 6 upon 3x plus 2. Now this is infinite limit. So answer to this question will be coefficient of highest power of x in the numerator as well as highest power of x in the denominator. In the numerator it is minus 6 and the denominator it is 9. So value of this limit is minus 2 by 3. So answer to this limit is e to the power minus 2 by 3. Now in part B it says two squares are chosen at random on a chessboard. What is the probability that they have a side in common? So if we look at a chessboard, then now there are 4 corner squares. So the probability of choosing any one square from these 4 corner squares is 4 by 64. And if we choose corner square, it has 2 neighbors. So if 2 squares, they have a side in common, then we need to choose any one of these 2. So it can be done in 2 by 63 ways. Now next we have the squares which are on the edges but other than corner squares. Now we have 6 here. We'll have 6 on this side, 6 on this side and 6 on this other side. So in all there will be 24 such squares. The probability of choosing any one square from these 24 squares is 24 by 64. Now for each of these squares we have 3 neighbors, 1, 2 and 3. So we need to choose any one out of 3, which can be done in 3 by 63 ways, and then plus if we choose any of these squares from remaining squares. Now total number of remaining squares will be 6 into 6, 36. So probability will be 36 by 64 into, so each of these squares has 4 neighbors. So we can choose any one out of 4. It can be done in 4 by 63 ways. So this required probability is 4 into 2, 8 plus 72 plus 144, which is 224 upon 64 into 63. Now this is 16 and 8, and this is 8, and this is 7 and 2, and this is 9. So this required probability is simply 1 by 18, and that is the answer to this question. Now question number 2 is, a pizza chain offers cheese pizzas with the choice of these toppings: pepperoni, onion, sausage, mushroom, and explain why the pizza chain can claim to offer 32 different pizzas. Now for any pizza, for every topping, we have 2 options. Either we can include that topping in the pizza or we can exclude it. So for pepperoni, we have 2 options. So it will be 2. Now for onion also, we have 2 options. In the same way, we have 2 options for each of these 5 toppings. So total number of combinations of these 5 toppings is nothing but 2 to the power 5, and that is 32. So this pizza chain can claim to offer 32 different pizzas. Now part B is, we need to evaluate this integral, which is dx upon, now we can write sin 2x as 2 sin x into cos x. So we'll write this as sin x and this is 1 plus 2 cos x. Now what we'll do is, we'll multiply and divide it with sin x. So we can write this as sin x dx, and sin square x is 1 minus cos square x. So we'll write this as 1 minus cos square x into 1 plus 2 cos x. Now what we'll do is, we'll let cos x as t, then minus sin x dx will be simply dt. So now it will be this minus dt upon 1 minus t square and 1 plus 2t, which we can also write as dt upon t minus 1, t plus 1 and 2t plus 1. Now what we'll do is we'll use partial fractions to break up this expression. So it will be a upon t minus 1, b upon t plus 1 and c upon 2t plus 1. Now we need to find the value of a, b and c. Now if we put t as 1, it will be 1 by 2 and 1 by 3. So value of a is 1 by 6. Now for b, we'll put t as minus 1. So it will be this minus 2 into minus 1. So value of b is 1 by 2. And for c, we'll put t as minus 1 by 2. So it will be this minus 3 by 2 and 1 by 2. And that will be minus 4 by 3. So we can write this integral as 1 by 6 log t minus 1 plus 1 by 2 log mod t plus 1 and minus 4 by 3 log mod 2t plus 1 divided by 2 and plus c. Now we can cancel this 2 with 2. We'll replace t with cos x. So answer to this integral will be 1 by 6 log mod cos x minus 1 plus 1 by 2 log mod cos x plus 1 minus 2 by 3 log mod 2 cos x plus 1 plus c, and that is the answer to this question. Now here the question is, the number of people in a small town increases by 2%. That means growth rate is simply 2% and population in 1982 it was 12500. So value of P naught is 12500. What is the predicted population at the start of year 2022? That is, we have 40 years time frame. Now population after 40 year will be P naught and then 1 plus r by 100 to the power n. Now P naught is 12500 and this is 1 plus, now this is 2 by 100 to the power 40. So population after 40 years will be 12500 into 1.02 to the power 40. And that is the answer to this question. Now part B is two distinct integers a and b. They are picked up from the set 1, 2, 3, 4 up to 100 and multiplied. What is the probability that resulting number has exactly 3 factors? Now we know that any number, it will have exactly 3 factors if and only if it is square of some prime. In that case, number of factors will be simply 2 plus 1. In all other cases, it can't be done. So that means out of a and b, one of the number, it must be 1. Either a must be 1 or b must be 1. And the other number, it must be perfect square of some prime. So this b, it can be either 2 square, 3 square, 5 square and 7 square. After 7 square, the number will be greater than 100. And if b is 1, then a can be 2 square, 3 square, 5 square and 7 square. So this required probability is total number of favorable cases. So total number of favorable cases we have is 8 and total number of cases is we can choose a and b in 100 into 99 ways, which is 2 upon 25 into 99, and that is the answer to this question. Now question number 4 is the integers x, y and z are in GP such that y minus x is a perfect cube and this expression log is equal to 6. Find the value of x plus y plus z. Now we can write this as log, now 36 is 6 square, so it will be this 2 and 6 square is 1 by 2 log x base 6. Now here this is log under root y base 6 and this is 216, which is 6 cube. Now 3 and 3 will cancel, so it will be 3 by 3 log under root y into z and it will be equal to 6. Now this 3 by 3 will cancel, 2 and 2 will also cancel. So we can write this as log xyz will be equal to 6, or xyz is 6 to the power 6. Now since xyz they are in GP, then x into z is y square. So basically y cube is equal to 6 to the power 6, or y is simply 6 square, that is 36. So now we have value of y, and value of y is 36. Now when we say x into y into z is 6 to the power 6, it clearly means it is equal to 2 to the power 6 into 3 to the power 6. Now from this we can say z is positive, and if z is positive, x is also positive. So that means both x and z, they are positive numbers, and they have to be some factor of 2 to the power 6 into 3 to the power 6. Now it says it should be such that y minus x, which is 36 minus x, it should be perfect cube of a number. So we have to choose this x in terms of any factor of 2 to the power 6 into 3 to the power 6, so that it becomes a perfect cube. Now we know that 27 is a perfect cube, and 36 minus 9 is 27, and 9 is a factor of 2 to the power 6 into 3 to the power 6. So basically we can take x as 9. So value of x here is 9, value of y is 36, and since it is a GP with common ratio 4, value of z will be 36 into 4, which is 144. Now we need to find the value of x plus y plus z. So it will be 9 plus 36 plus 144, and it will be 189. And that is the answer to this question. Now in part B it says, if a plus b plus c is 0, then prove that a cube plus b cube plus c cube is equal to 3abc. Now there are n number of ways to solve this, and one of the way of solving it is, we can start with a plus b plus c into a square plus b square plus c square minus ab minus bcn minus ca. Now if we multiply everything, we'll get this as a cube plus b cube plus c cube and minus 3abc. Now the question it says a plus b plus c, it is 0. Now we put it equals to 0. This expression on the right hand side will also be 0. So from here we can say, if a plus b plus c is 0, then a cube plus b cube plus c cube, it must be equal to 3abc. And that is the answer to this question. Now question number 5 is, the carbonitrided bushes need to meet the specifications on surface finish, case depth and dimensional variation. Otherwise the bush is considered as a defective bush. Now we have a batch of 240 bushes, and out of them 30 do not meet the specification on surface finish. So the probability that the bush is not going to meet surface requirement is 30 by 240. And if it doesn't meet case depth requirement, that is PC, probability is 15 by 240, and dimensional variation, suppose PD, will be 9 by 240. Now it says 6 on both surface and case. So that means this probability of S intersection C, it will be 6 by 240. Surface and dimensional S intersection D, it will be 4 by 240, and 4 on case depth and dimensional variation. So C intersection D is also 4 by 240. Now it says there is no bush not meeting specification for all three. So that means probability of S intersection C intersection D, it is 0. Now we need to find the chance that a bush randomly selected from the batch will be a defective bush. Now a bush will be defective if it has a problem in either surface finish or case depth or dimensional variation. Now this is equal to PS plus PC plus PD. So it will be 30 by 240 plus 15 by 240 plus 9 by 240, and then minus S intersection C, 6 by 240 minus 4 by 240 and minus 4 by 240 plus 0, and which comes to 40 by 240, and which is 1 by 6. So the chance that a bush randomly selected from the batch will be a defective bush will be 1 by 6. Now the part B, it says, consider the integers x1, x2, x3 which are in GP. The fourth term is 24. So fourth term is AR cube and it is 24. The ratio of third and fifth term is, so third term is AR square and fifth term is AR to the power 4, and this ratio is 1 by 4. Now I'll cancel, so we get R square. So value of R square, it is nothing but 4. Now we need to find second term. Now second term is simply AR. Now we can write this as AR cube upon R square. Now AR cube is 24 and R square is 4. So second term is basically 6. Now 6 says, consider a polynomial gx which is x to the power 4 plus ax cube plus bx square plus cx plus d, where a, b, c, d are some real numbers, and suppose x equal to 0 is the only real solution of g dash x equals 0, and it is also given that g minus 2 is less than g2. Find the maximum value of gx in the interval minus 2 to 2. Now we know that g dash x for this function will be 4x cube plus 3ax square plus 2bx and plus c. Now g dash 0 will be 0. That means from here we'll get this condition that value of c, it must be 0. So now we can write g dash x as x into 4x square plus 3ax plus 2b. Now it says it has only one real solution, and that is x equals 0. So this quadratic equation, it must not have any real solution. That means value of d in this case is less than 0. So from here we'll get 9a square minus 32b will be less than 0. Now if we look at 0, now rightmost is positive and left hand side is negative. So this function, it decreases and then it increases. So for this function in the interval minus 2 to plus 2, critical points are x equal to minus 2, x equals 0 and x equals 2. Now x equal to 0, it is a point of local minima. So it will have maxima at either minus 2 or plus 2. But in the question it says g minus 2 is less than g2. So maximum value of gx in this interval will be at 2. So maximum value of this function will be g2, and g2 will be 16 plus 8a plus 4b plus 2c plus d, subject to the condition that c is equal to 0 and 9a square minus 32b is less than 0. So the maximum value of gx in this function is g2. Now it says in a transaction process consisting of three activities, namely allocation, task processing and quality check. So we have allocation, task processing and quality check. 9 employees including 5 male and 4 female. So we have 5 males and 4 females who are working. 2 of them are process leads, 4 perform processing, remaining 3 are quality auditors. Now out of the 4 female employees, 1 is a process lead. So we have 1 male processing lead and 1 female processing lead. 2 are processing executives. So we'll have 2 and 2 here, and then the remaining 1 is a quality auditor. So one of the female is quality auditor, whereas we have 2 male quality auditors. Now suppose the chance of allocating a task is equal among the process leads, equal among processes and equal among quality checks. What is the probability that the task is completely handled by a female employee? Now for this, required probability will be auditor has to be female. Here we have 2 people, out of which 1 is female. So this probability will be 1 by 2 into. Now for the second one, this probability will be simply 2 by 4, which again is 1 by 2. And for quality it is 1 by 3. And the process of choosing an employee across any process, it is independent. So this required probability is simply 1 by 12. Now question number 7 is, success in a roll of 6-phase balanced die is defined as hitting a 6. So probability of success is 1 by 6. That means probability of failure is 5 by 6. Now it says, let P denote probability of success if the probability of obtaining at least one success in n repeated rolls is greater than or equal to 0.9. So that means probability that x is greater than or equal to 1, it is greater than or equal to 0.9. What is the smallest possible value of n? Now we know that probability of x greater than or equal to 1, it is also written as 1 minus probability of x is equal to 0, and it should be greater than or equal to 0.9, or probability of x equal to 0, it should be less than or equal to 0.1. Now probability of x equal to 0 is nc0, p to the power 0, q to the power n, and will be less than 0.1. Now q is 5 by 6 to the power n, and will be less than 0.1. Now if we take log and solve, we'll get this n, it should be greater than or equal to 12 point something. So basically the smallest possible value of n must be 13, and that is the answer to this question. Now in 7th B, we are given, in an agile software development process, the sprint productivity is related to developer experience, review time, and code reuse as follows. So SP is equal to 1.33 plus 0.05 DE minus 0.01 RT and plus 0.02 CR. The mean and standard deviation of developer experience, review time, and code reuse is given in the table below. What will be the variance of sprint productivity? Now in this case, all the variables, they are linearly related, but then we have to make an assumption in order to solve this question, and the assumption is these random variables, they are independent of each other and they are not correlated. And if they are not correlated, then we can simply write variance of sprint productivity will be equal to 0.05 square into variance of developer experience plus 0.01 square into variance of review time plus 0.2 square into variance of code reuse. So it will be this 0.05 whole square into, now its variance will be 0.5 square. Now this is 0.01 square into 2 square, and this is 0.02 square into 10 square, and that is the answer to this question. Now question number 8 is, suppose the solution of equation are real numbers and difference between the solution is less than under root 8. So difference between the roots, under root mod alpha minus beta, it is less than under root 8. Now we square it, we can write alpha minus beta square will be less than 8, or alpha plus beta whole square minus 4 alpha beta will be less than 8. Now alpha plus beta square is a square, and then alpha beta is 2, so it will be minus 8 is less than 8, or a square minus 16 is less than 0. So this is minus 4 and plus 4. So value of a should lie between minus 4 and plus 4. Now part B, it says, according to the service level agreement between the client and an IT company, the daily average resolution time of tickets should be within 24 hours. And if any ticket takes more than 30 hours, the IT company has to pay a penalty of $5 to the client. On a particular day, the IT company receives 6 tickets to resolve, and later it was found that the average resolution time for that day was 24 hours. So we have 6 tickets, say X1, X2, X3, X4, X5 and X6, which denotes time taken by each individual tickets, and their average is 24. The further investigation reveals that 2 tickets out of 6 has taken more than 24 hours to resolve. When the resolution time of these 2 tickets are removed, the resolution time average reduces to 23 hours. Whether the IT company paid any penalty on that day, if yes, how much? Now, we'll divide this data in 2 sets, set of 4 and set of these 2. For these 4, average is 23, and for these 2, let the average be A. So we can write average of this group as 4 into 23 plus 2 into A upon 6, and it is equal to 24. So from here we can write 2A, and it will be equal to 144 minus 92, which is 52. That means value of x5 plus x6, it is equal to 52. And their average is 26. Since the average is 26, one of the ticket is less than 26 and the other ticket is greater than 26. Now we need to find if it is possible for any ticket to have resolution time more than 30. Now both x5 and x6, they are greater than 24. So if we take minimum value of x5, then we can say maximum value of x6 will be simply 52 minus 24, and which is 28. So in any case, both x5 and x6, they'll take the value less than 30. In that case, the company doesn't need to pay anything on that day. So answer is no. Company doesn't pay anything as penalty.